Hey everybody, this week we are going to be moving into our next set of identities, which are our double and half angle identities. So first off are our double angle identities. Again, these are very similar to how we've been working with things in the past. The formulas just look a little bit different. These are when we're working with angles, again, that we can't find on the unit circle. Sometimes we can manipulate them so that we can find angles that are found on the unit circle. So last week we were adding and subtracting fractions and angles, trying to make them into those angles that we're used to working with. In this case, in this week, we're going to be multiplying. So as you can see, there's one formula for the sine double angle identity, three equations or formulas available for the cosine double angle identity. You just want to pick which one makes the most sense to you to given the situation, and then one formula for tangent. As with many of our identity problems, it's often just easier to jump into examples and kind of explain them as we go. Excuse me. So in this problem, it's saying that if the cosine of theta is 8 over 17, and the angle and that theta angle that we're dealing with is between 3 pi over 2 and 2 pi, it's asking for us to find the sine of 2 theta. Well, first off, let's figure out the equation that we're going to use for the sine of 2 theta. If you look at your formula chart, the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. So if this angle that we were talking about, if we weren't talking about it in terms of theta, if that was actually a number that wasn't on the unit circle, but the angle theta itself was, or if we were to be able to figure out what angle would go in there, we can actually break this down into 2 times the sine of that angle theta times the cosine of that angle theta. So what we're going to do is we're actually going to figure out where this angle is, determine what the sine value is, and then just plug it in. So if we're talking about 3 pi over 2 to 2 pi, we're actually talking about quadrant 4. So that's down here. So this is our 3 pi over 2, and this is our 2 pi. So the angle that we're talking about is going to be somewhere in here. Okay, so this is our angle theta. We always go back to our bow tie. We know the cosine. So cosine is adjacent over hypotenuse. Remember SOHCAHTOA. So adjacent is going to be 8, hypotenuse is going to be 17. We're going to use the Pythagorean theorem, and we're going to say that 8 squared plus, we'll call that x squared, equals 17 squared. Well, if we do those through, we're going to find that 17 squared minus 64 is going to give us that x squared is equal to 225. So x has to be 15. So we can fill that in on our triangle. So now we can figure out that the sine of theta is opposite over hypotenuse. So opposite is the 15 over hypotenuse is 17, but since we're in quadrant 4, that's actually going to be negative. So now we know our sine and our cosine, so we can fill in that entire formula. So we're looking to fill in 2 sine of theta times cosine of theta. That's what this sine of 2 theta is equal to. So we've got 2 times the sine of theta is negative 15 over 17, and the cosine was given, we've got 8 over 17. When we go through and multiply all those through, we're going to find, so multiply all your numerators, multiply your denominators, we're going to end with negative 240 over 289. And that is your final answer for this problem. You're just taking those values in and plugging them into the formula. Number 2 is very similar. We're given the sine value, we're given one of the trig values of this theta angle. We're told where the angle happens in between pi and 3 pi over 2, and we're told to find the tangent of 2 theta. So let's start with that. We're going to go up to our formula list. The tangent of 2 theta is equal to 2 times the tangent of theta over 1 minus tangent theta squared. Sorry, tangent squared of theta. So we need to be able to figure out what tangent is of this angle. So we have to go back, we'll draw our coordinate plane. The quadrant that they're talking about is between pi and 3 pi over 2. So if you guys remember, here's pi, here's 3 pi over 2. So our angle is going to be in quadrant 3. So somewhere in here, we always relate back to the x-axis. So here's our theta. Sine is -1/3, so that's opposite over hypotenuse. So the opposite is -1, hypotenuse is 3. We also know that our cosine, our x value, is going to be negative as well because we're in quadrant 3. Tangent will be positive. So again, we're going to do Pythagoras, and we will say that -1 squared plus x squared equals 3 squared. So 1 plus x squared equals 9, x squared equals 8, and then we'll have the square root of both sides, so x equals, in this case, it's going to be the negative square root of 8, which is going to be -2 square roots of 2. Okay, and we know it's negative because of the quadrant that it's in. So now we need to look back and say, okay, the formula that we're working with asks for us to know the tangent of this angle. Right now we know sine, we can figure out cosine, we can also figure out that the tangent of theta is equal to the opposite over the adjacent, or in this case, opposite, -1 over adjacent, -2 square roots of 2. So we're getting closer. The negatives are going to cancel out. We're going to have a positive tangent, which makes sense because we're in quadrant 3. But now we have to rationalize. So we're going to multiply both the top and the bottom, both the numerator and the denominator, by the square root of 2. So that's going to give us the square root of 2 over 2 times 2 is 4. So the tangent of theta is equal to square root of 2 over 4. Now we can take this and plug it in our equation. So now I'm going to take this equation. I'm going to start right down here. 2 times the tangent of theta is the square root of 2 over 4 over 1 minus the tangent of theta, which is the square root of 2 over 4 squared. So the 2 is going to cancel with the 4. So I'm left in the numerator with the square root of 2 over 2 over 1 minus square root of 2 squared is 2 over 4 squared is 16. We can simplify that 2 over 16 down to 1 over 8. So now we can rewrite this as the square root of 2 over 2 over, we're going to do 8 over 8 minus 1 over 8. So now we have the square root of 2 over 2 over 7 over 8, which is the same thing as the square root of 2 over 2 times 8 over 7. I always like to make things smaller if I can. So the 2 will cancel out with the 8, both divisible by 2. And we're left with 4 times the square root of 2 all over 7. And that is going to be your final answer. So a lot of steps to this one, but I do feel like we've done a good job this year of building onto how to figure out all of these steps. The beginning is drawing the triangle in the right quadrant. Second part is using SOHCAHTOA to figure out what the tangent is. And then the third is just plugging it into that equation and knowing how to work with exponents and fractions. So hopefully that feels good for you guys. So next in your notes is problem number 3. Be sure to give that a try on your own. So that wraps up our double angle identities. Now we're going to move into the half angle identities. So instead of multiplying things by 2, now we're dividing angles by 2. So again, we're looking at angles that we don't necessarily know from the unit circle, and we're trying to turn them into ones that we do. For half angle identities, we have 5 different equations that we can work with. One for sine, one for cosine, and then 3 different ones for tangent, depending upon what information you know and what looks like it would make the most sense for you to work with. So feel free to have these with you when you're working on your problems at home, and we'll jump right into some examples. All right, the first thing we want to look at when we're going to try to figure out the exact value of the expression is we have to figure out what quadrant this angle is going to be in, which is going to be the deciding factor on what sign, S-I-G-N, our final answer has. So 76.5 degrees, if we think about that, that's between 0 and 90, so that is going to be in quadrant 1. So the cosine of this angle is going to be positive. So whatever other math we do from here, we know that our final answer needs to be positive. That's what we're going to start with. So 67.5 is not an angle on the unit circle. It's not one that we know or can figure out x and y coordinates for. But if we take this value and we multiply it by 2, we end up with 135, which is an angle that we know on the unit circle. That happens to be in quadrant 2, but it has the same reference angle. So what we're going to do is we're going to say we've got this 67.5. That is the same as 135 divided by 2. So the cosine of 67.5 degrees is the same as the cosine of 135 degrees divided by 2. So not the whole thing, but the 135, that divided by 2. Okay, so 135 degrees is something we can work with. That's an angle we know. So we know that the cosine of with a half angle identity is plus or minus the square root of 1 plus the cosine of the whole angle over 2. So this angle, the 135, that's your new theta, because what we're working with is that theta over 2. Now the other piece to consider, we already decided that the 67.5 degree angle is in quadrant 1, so our final answer has to be positive. So we don't have to worry about that negative anymore. We're only going to think about the positive square root. Now we can start to fill things in. So we have the square root of 1 plus. So 135, we have to find the cosine of 135, which is going to be over here in quadrant 2 with a 45-degree reference angle. So the cosine is going to be the negative square root of 2 over 2. So this is 1 plus, if we go back to our formula, 1 plus negative square root of 2 over 2 all over 2. Now I have to just work with this, do some algebra to combine it and make it in the most simplified form I can. So this is going to be the square root of, I'm going to change that 1 to 2 over 2 minus the square root of 2 over 2 all over 2. That is a lot of 2's. So I'm going to combine this. So now I have the square root of, it's the square root of that whole thing. Be aware of that. 2 minus the square root of 2 over 2. Instead of saying divided by 2, I'm actually going to take that and I'm going to move it out to the side and I'm going to say that I'm multiplying by 1/2. Those are technically the same thing. All I'm doing is making it so that I can combine that fraction now. So this is going to give me the square root of 2 minus the square root of 2 all over 4. When I have the square root, when I'm taking the square root of a fraction, I give that square root to both the numerator and the denominator. So now I have the square root of 2 minus the square root of 2. Yes, we have two square roots in the numerator. That's okay. It looks weird, but it's okay. Over the square root of 4. Well, we know what the square root of 4 is, so we can simplify this further to 2 minus the square root of 2 all over 2. And that is going to be your final answer. It does look messy. It does look a little weird. We don't normally have a radical inside a radical, but it is okay. This in your calculator would give you the exact answer for the cosine of 67.5. If you were to type this whole equation in and you were to type in the cosine of 67.5, they would be exactly the same. All right, now we're going to do another half angle identity, this time with a tangent function. So the thing that's going to give away that you should be looking for a half angle identity is whenever we have this 0.5, we don't have any angles that we know of necessarily on the unit circle that we can give the exact sine and cosine values for. So anytime you see that 0.5, chances are if you multiply that angle by 2, it's going to end up being something on the unit circle that we're familiar with. So we're going to rewrite this problem as the tangent of, if we multiply 157.5 by 2, that becomes 315. So this is the same as the tangent of 315 over 2. If we use our half angle formula for a tangent, remember this is theta on the top, theta over 2, that's going to give us, our tangent expression says that we've got the sine of theta over 1 plus the cosine of theta. So in this example, it's going to be the sine of 315 degrees over 1 plus the cosine of 315 degrees. So now our job is just to figure out what the sine and cosine of 315 degrees is, or they are. So 315 degrees is going to be 45 degrees shy of 360. So our coordinates are going to be square root of 2 over 2 and negative square root of 2 over 2. Those are our two coordinates. So we've got our sine is the y value and our cosine is the x value. So we can simplify this further that the sine of 315 is negative the square root of 2 over 2 all over 1 plus the cosine of 315 is the positive square root of 2 over 2. I need to simplify the denominator first, so I'm going to make this negative square root of 2 over 2 over 2 plus the square root of 2 over 2. So I basically turn this 1 into 2 over 2 so that I could combine them. Now I'm going to do keep change flip, so negative square root of 2 over 2 times 2 over 2 plus the square root of 2. Nicely, these guys cancel out, and now I have negative the square root of 2 over 2 plus the square root of 2. So this is all fine and dandy, except that now I need to multiply to get rid of the radical in the denominator. So I'm going to multiply both the numerator and the denominator by 2 minus the square root of 2, 2 minus the square root of 2. When I do that, I'm going to move over and give myself some room here. Negative square root of 2 times 2 gives me negative 2 square roots of 2 plus the square root of 2 times the square root of 2 is just 2 over, here's where I FOIL, so 2 times 2 gives me 4. Then I've got 2 times the square root of 2 and 2 times negative the square root of 2, so those are going to cancel out. And then I've got the square root of 2 times negative square root of 2, so this will be minus 2. So many 2's. So let's simplify this. Now we've got negative 2 square roots of 2 plus 2 all over 2. The nice thing here, we've got our beans. I can cancel out the 2 there and the 2 there. So I'm left with negative square root of 2 plus 1. Or if I want to rewrite this a little more correctly, 1 minus 1 minus the square root of 2. If you want to double check, which would be really good to do, the square root of 2 is about 1.4, so it's bigger than 1. So if we were to actually do out this subtraction piece here, we would have a negative answer. We know has to be right because if we go back to our original part of the question, we have the tangent of 157.5. That 157.5 is going to be in quadrant 2. And tangent is also negative in quadrant 2, the same way it is in quadrant 4. So it makes sense that our final answer is 1 minus the square root of 2. All right, number 6. So again, step 1, we always want to think about what quadrant our final answer is going to be in, and therefore what the sign is going to be, SIGN, of our final answer. So 11 pi over 12 is in quadrant 2. Since we're dealing with sine, that means we're going to have a positive final answer. Okay, so now 11 pi over 12 is not one that we work with on the unit circle, but we can turn it into one that is. So 11 pi over 12, this one's a little tricky to see. Sometimes these fractions are hard. If we have 11 pi over 6 times 1/2, that would give us this 11 pi over 12. So this is what we want to do. Well, times 1/2 is the same as division by 2. So that's how we can write that to end up with our half angle formula. So I'm going to rewrite this as the sine of 11 pi over 6 over 2. And then this 11 pi over 6, this is my theta in my half angle formula. So I'm going to use my formula, and that gives me plus or minus, but we know it's positive, so I don't even have to write it. 1 minus the cosine of theta all over 2. Okay, so we have to think about 11 pi over 6. Think about where that would be on the unit circle. That's going to have a reference angle of pi over 6. So the cosine is going to be the square root of 3 over 2. 1 minus the square root of 3 over 2. And 11 pi over 6 is going to be just shy of 2 pi. You can draw it over here. just shy of 2 pi, so my cosine value will be positive. So this works out just right, 1 minus a positive 3 pi over 2 all over 2. Now we just have to rewrite everything so that we can combine it and simplify it. So I'm going to change this 1 here to 2 over 2. That's going to be the same thing, but it allows me to subtract. With a common denominator. So now I've got 2 minus the square root of 3 over 2 all over 2. This is the same as the square root of 2 minus the square root of 3 over 2 times 1/2, which is the same as, we're going to multiply those denominators, 2 minus the square root of 3 over 4. When we have a radical over a fraction, we give it to both the numerator and the denominator. 2 minus the square root of 3 over the square root of 4. Simplify that, and we've got 2 minus the square root of 3 over 2. And that is going to be your final answer for number 6. So number 7 is the last one for this video, and it's similar to our other problems in that we're still going to be using those half-angle formulas, but it is a little bit different because now we're not necessarily working on the unit circle anymore. We're actually given the cosine value, and we have to work with it from there. So what we're going to do here is the sine of theta over 2. If we go back to our formulas, what we need is, this is 1 minus the cosine of theta over 2. Well, if you think about it, we're given the cosine of theta. That's what's given in the problem. We're given this cosine of theta. So it works out pretty well that we don't have to do a whole lot of work here. What we do need to figure out, though, is what the sine, S-I-G-N, of this sine of pi over 2 is going to be. So this is talking about right here that the angle is located between pi over 2 and pi. On our coordinate plane, here's our pi over 2, and here's our pi. This is where the angle is going to be in quadrant 2. In quadrant 2, the sine is always going to be positive because we're above the x-axis. So we have this positive square root of 1 minus the cosine of theta over 2. That's how we determine the sine. So now we just have to plug it in. So I'm going to rewrite the equation just so we can find it again. So we've got square root of 1 minus the cosine of theta over 2. Now we're going to plug in the cosine of theta, which is this whole fraction, 1 minus negative 3 over 8 all over 2. I'm going to change this 1 to 8 over 8. So now, and this is minus a negative is the same as plus a positive. So I have the square root of 8 plus 3 over 8 all over 2. I can simplify that, so I have the square root of 11 over 8 all over 2. Just like we did on the last one, what I'm going to do is, instead of having divided by 2, I'm going to turn that to times 1/2. So now I have the square root of 11 over 8 times 1/2, which is the same as the square root of 11 over 16. When I have a fraction or radical, I'm going to give it to the numerator, and I'll apply it to the denominator as well. So I have the square root of 11 over 4. And that's my final answer. So on problems like this, we're given the trig function that we need. We don't have to go to the unit circle. We don't have to figure out what the x or y value is. It's given to us right here. So it's a lot more algebra oriented, and just understanding what those formulas are and how to use them. So that is everything for this video. If you guys have any questions, please reach out. There are a couple more problems in the notes that I do want you to finish up on your own, numbers 8 and 9, as well as going back to number 3. As always, if you have any questions, you know where to find me, and I would be happy to give you any help I can. Hope y'all are doing well, and I will talk to you soon.